So 2.9 says the radius of an atom is on the order of 10,000 times as large as its nucleus. If an atom were enlarged such that the radius of its nucleus were 1 centimeter, that would be the radius. What would be the radius of the atom in meters and in miles? And then they give us a relationship there between miles and meters. So for 2.9, similar to the last one, they're starting off by giving us a relationship. They're saying there's a relationship between the radius of the atom, which is everything, including the protons, neutrons, and electrons, compared to the radius of just the nucleus. So they're saying for every one nucleus radius, or if we think about the radius of the nucleus, there's a relationship between that and the radius of the atom, or the relative size. So is it correct to say one nucleus is equal to 10,000 atoms, or one atom is equal to 10,000 nuclei? Right. If we have a relationship and we know which of the two things is smaller, to set them equal, we take the relationship between them as a large positive number, put it with the smaller of the two units, and that will make it equal to one of the larger units. So to set up that relationship, we would say that the radius of every one atom is equal to 10,000 nuclei. So I can use that as a relationship. So that's just the first sentence of the problem is a relationship. We just have to know how to interpret that relationship so we can use it as a conversion. Then it says, if the nucleus were enlarged to the size of 1 centimeter, what would be the radius of the atom in meters? So how many meters would be equal to an atom? So they're also telling us that the nucleus is equal to 1 centimeter. They're also giving us that relationship. So a nucleus's size isn't actually 1 centimeter, but they're saying if the atom were enlarged so that the nucleus were 1 centimeter, so they're saying in this specific instance they want you to assume that the size of the nucleus is equal to 1 centimeter. So that's another relationship. Yeah, first they ask for it in meters though. So I want to make sure, because at the end they give us a relationship between miles and meters. So in order to get to miles, we have to get to meters first, because that's another relationship. So yeah, I guess if we're just looking at, if we just wanted to know about the miles, we could ask for that in miles. We could start off with that in miles. We have all the relationships we need to do that conversion. So what should I be plugging in here? How do I get these relationships to give me the answers that I'm looking for? Yeah, so can we, I mean, I agree with your approach. What would, if we were going to kind of do that step by step, so that you don't have to think it all through in your mind at once, because that's difficult for most people, what would be the first thing of the relationships we had that you'd put in? Okay, so you want to start with this relationship. One atom over 10,000 nuclei. Sometimes if you're not sure what to put in, you can just put in relationships and use some trial and error and see if it gives you the units you want in the end. You might want to start it that way. You might also want to say, I want units of miles in the end, right? I have a relationship that involves miles. Maybe I want to start with that relationship. I know that for every 1 mile, that's equal to 1609 meters. If I can get the in this one here, if I can get the meters to cancel, then I'll have miles. And that's the unit I want. That would probably be the way I would set this up, because at least I know the unit I want is on top of the fraction, the units of miles, and I can think about canceling the other things. So if I want to cancel them, if I want to focus in on this one, we can look at the other one as well, but if I want to focus in on this one and cancel the meters, how do I do that? I don't have any relationships written down that involve meters, so I need another relationship. I do have a relationship involving centimeters, so that could be useful if I could convert what I have into centimeters. Right, so centi is a 10 to the negative second. Meter is a base unit, 10 to the 0, so the difference between a centi and a base unit is 2 powers of 10. I'll put that with the smaller of the two and set it equal to 1 larger unit. So 10 to the second centimeters equals 1 meter. So I can apply that now to cancel the meters. So now I've got miles per centimeter. Yes? Yeah. The metric table is on the formula sheet. So as long as you can use the metric table when you have two metric prefixes and you can see the difference in the power of 10 and set that up in your relationship, then you should be fine. You don't have to memorize those powers of 10. Just how to use them. So if I want to keep track of what I have canceled so far, now I've got centimeters. How do I cancel centimeters? Well, I've got this relationship, so maybe I apply that. 1 centimeter equals 1 nucleus. It's not really true, but they're saying we're blowing up the atom so that its nucleus has a radius or a distance of 1 centimeter. And now I can apply this relationship. I can say that 10,000 nuclei are equal to 1 atom. So in the end, the units I get are miles per atom. Is that what it was asking me? It's saying, what would be the radius of an atom in miles? Or how many miles are there per atom? So that means I've got the units I want. So sometimes it might not be obvious that when they're asking for a unit, they might be asking for you to express something in terms of 1 unit per another unit. When you look closely at this question, it looks like it's just saying, what is the distance or what is the radius in miles? But really what they're asking is, what is the radius of 1 atom in miles, or the radius in miles per atom, or the miles equal to 1 atom or per atom. So really the units I was looking for was per atom. I don't need to necessarily recognize that right away, because eventually I'll get to this point, and when I get to this point I'll realize there's no way for me to cancel the atoms. And so I'll think, well, is it okay if my units are miles per atom? Yes, that's what the question was asking. Per every 1 atom, how many miles would that be? So then I just need to plug into my calculator, which would be all the numbers on top multiplied together, and they're all 1s except the 10,000. So 10,000 divided by 1069 divided by E2, and that gives me, okay, yeah, there, that's our answer. In terms of sig figs, the question is poorly written because they're giving us information that is not clear how many sig figs are associated with it. If you just say 10,000, that's not a good way of communicating sig figs. It's not certain if you say 10,000 whether that's one sig fig or whether it's more than one sig fig. So in this case, because the question is worded poorly, I wouldn't expect you to be able to identify the sig figs in the end. If this were given as like 1.0 times 10 to the fifth, which would be equal to 10,000, nope, fourth would be equal to 10,000. That would have two sig figs, and so then I would limit my answer to 2. If I were to think about this approach up here, and I were to work with that, and I would continue with the conversions, I would find that as I go through, canceling nucleus, canceling centimeters, canceling meters, I would find that as I cancel my units, that what I have are atoms per mile. That's a different thing, right? So if you're working with some trial and error, if you're not sure how to set things up, you can start by putting relationships in and then look at what the units are in the end. If the question was asking how many atoms would fit in a mile, then this would be the conversion I would use. But if the opposite is the question, how many miles would one atom take up, then I realize I don't have to redo it. I've really got a lot accomplished here. I just have to flip every single one of these to get miles per atom instead of atoms per mile. So there shouldn't be any blank answers on your exams if it's a conversion question. I mean, even if you don't have any idea where to start, look at the relationships. Just write down the relationships that are given the best you can. And then just start putting some of them in. And see if, see if that gives you some units that look familiar, and then maybe you can work from there.